Hey guys, welcome to another video. So today we continue on with simple harmonic motion under the extension 2 topic of mechanics. If you haven't already done so, please check out the first video, which laid down the foundation and the framework for some of the questions. Also, if you haven't done so, please subscribe to the channel, like the videos, and tell your friends. So today, this video, we're going to explore some further questions on simple harmonic motion, where the first question that I want to show you, there's a question that they always, or not always, sometimes they put in where they ask you about total distance traveled or how far has a particle traveled. There's two ways to do it. There's one way where you basically look at the cases of turning points. Another way uses integration. So let me explore that with you. And then also I want to touch on a few sort of special cases where simple harmonic isn't given to you in terms of trig functions like sine and cos. It's given to you in the function v squared equals to some sort of function of x. So let's begin with reminding ourselves with the formula, or the formulae, right? So simple harmonic, if I had the origin there and let's say my particle oscillated between the center point there and these are the endpoints, right? So basically I have a particle here that moved left and right, oscillating between the two, right? So in this case here, then I know, right, at the center here, x equals to c, at the endpoint, v equals 0, right? Just to really bring that back now, the formula at play here is that I have acceleration to be expressed as n squared x minus the center, and that is my equation of motion. Right. Now, so last week we basically explored cases that usually revolve around trig, and there's buzzwords like, you know, if they say initial, time equals 0. If they say at the origin, x equals 0. At the center, x equals c, etc. At rest, v equals 0. Now, with this in mind, I don't think I want to write down any more theory. Let's dive right in, explore some past paper questions. The first one's a nice one. Just note the last question, right? So let's dive right into it. From Sydney Grammar 2009, you can see this question is quite, I mean, it's quite straightforward, right? X is expressed as a function of t, right? Pretty straightforward. Find velocity, find acceleration. I mean, these two, classic, right? We're just going to differentiate twice to get 1 mark each to get those. Comes to rest for this one. Now let's label that as a buzzword there. Comes to rest means v equals 0, and it goes find time. So find t. Where does it come to rest? Once again, rest, but the word where there means that instead of finding time, the rest, let me just write that as v equals 0. Where instead of finding time, we're finding x, right? Question mark. And the last but not least, how far does a particle travel in the first 2 seconds? Now, I want to explore that, right? That's the point of this question. So last week, I mean, questions 1 to 4, very similar. So we're not covering new ground there. It's part 5 that I want to show you almost 2 options for you to consider. So let's quickly do parts 1, 2, 3, 4 as fast as we can. So let me just shift over here a bit, give myself some space. Cool. So if x equals this, then quite simply, velocity is the derivative of that. So let's make sure I do it right. Squared plus 6t minus 18, right? Easy. That's part 1. I don't think there's anything. Let me just check my math. Perfect. Pretty straightforward. 1 mark there. And guys, part 2, acceleration. Differentiate that again. 24t plus 6, right? Tick, tick. Yeah, 1 mark each. Nothing fancy about that. Part 3, easy 2 marker. When it comes to rest, find the time. So basically sub in v equals 0 into this quadratic here. I'm hoping that's a factorizable quadratic. I think it is. Let's see. So maybe divide everything by 6, but you get 2t squared plus t minus 3. Yeah, that's factorizable. 2t, what's that? T 0, 3's over here, 1's over here. I want that positive, so that's plus and that's minus. So t equals to, well, negative 3 on 2, positive 1, which means t equals to 1 only, because time is positive. Yeah. So that's when it occurs. Nothing, too hard about that, right? Now, Next one, where does it come to rest? So I need to sub time equal to 1 into displacement, right? To find the where, to find the x value, right? Nothing too hard so far. So sub that into there when t equals to 1, right? X equals 2. So 4 times 1 cubed plus 3 times 1 squared minus 18 times 1 plus 1. Guys, punch in the calculator. I think it's minus 10 meters, right? So what that means is that it's traveling backwards. Actually, whether it starts at initially starts at 1 when I was having t equals 0 into displacement. It's gone back 11, right, to end up at negative 10. Nothing too hard about that, right? Nothing too hard. Now, part 5, right? This is the point of me including this question in the second video, right? Part 5, how far does it travel after the first 2 seconds? Now, it is incorrect for you to put in 2 into displacement and then get the answer. It is incorrect. Why? Because when you sub in 2 into displacement, you just found the displacement. You didn't find how far it traveled. How far it traveled, right, in this question is actually quite important. This implies distance, right? And distance isn't just about subbing in a time to find displacement, because that's where you ended up, right? That wasn't the journey at all. They want to know the journey, right? Now, so one way to do this, right, and I'll write this as method 1. Right? I'll write this as method 1. So method 1 is to basically track the distance traveled as it comes to rest, and then track the distance as it goes to the next point, right? So in this case, it only comes to rest once, right? And it comes to rest at 1 second. So if I was to plot, right, the movement on a number line, right? And this is the origin here. Now I know at time 0, right? If I sub in t equals 0 into initial displacement, I'm at 1, right? So I start off the journey, right? Let me map out the journey for you. I start off here. This is my t equals 0. Then what happens? At time 1, I end up negative 10. So maybe I'll extend this number line. Right, let me extend this number line back, right? And obviously not to scale. So at t equals to 1, I end up at negative 10, right? After 1 second, right? So 1 second, I'm here, right? 1 second. Yeah. And then now they want 2 seconds. So what I am going to do now, I'm going to sub in t equals to 2 to find out where I end up in my second, right? So let's do that. So when t equals to 2, sub that into displacement, and you get, what do you get? 4, 2 cubed plus 3, 2 squared minus 18, 2 plus 1. Right? Now, if you did the maths there, I think you get 9, positive 9. So what that means is in the second, it went from minus 10, in which case I know it came to rest, right? I know it came to rest at this point, it stopped, and then it reverted, right? It then went backwards, right? All the way till positive 9. Yeah. All the way to positive 9 for the second. Yeah. So it is first, right? Second, it went all the way back. Now, what that means, guys, is that the first second it traveled from 1 to negative 10, that there is 11 meters, right? The second one, it traveled from negative 10 to 9, what's that? 19 meters. So therefore, the total distance, right? Therefore, total distance. Yeah, how far did it travel? 11 meters plus 19, 30 meters. Does that make sense? So when you sub in t equals to 2, you find the position. You don't find distance, right? To find distance, you're actually going to map it out. Now, a lot of questions get asked, right, at this point. How do you know that's the total distance? Like, what if they did a lot more stuff? What if it wasn't the first 2 seconds? What if it was an oscillation and you just kept on, what if I said to you, how far did it travel in the first 15 seconds, right? You just got to keep mapping it. Now, there has to be another way, right? Then there has to be another way. And this other way uses integration, right? So what I'm going to show you now, sometimes, right, you just basically step right into the integration part off the bat, especially right? If they don't give you an expression for the displacement, sometimes they just give you velocity and they ask you, what's the total distance traveled? This is how you do it, right? Because conceptually, you can use integration to find this, right? And the integration rule is like this, right? Now, if I had this graph here and I plotted velocity, right? I plotted its velocity, right? Now the velocity formula, what is it upstairs? Let me grab it. Yeah, where is it? This guy here. Oops, grab too much. This guy, paste, move downstairs, right? Let's move it downstairs. Here it is. Right? Now, this is a parabola, right? In fact, I solved it, I got one root at 1 and one root at negative 3.5. So it should look like a positive parabola looking like root at 1, like that. Maybe I'll, let me just do it like this. Over here, there was negative 3.5, 1, so something like that, right? There's 1, there's negative 3 and 2. Now, why am I doing this? Because if you think about velocity, if I wanted total distance traveled, that is technically saying between the values of 0 seconds to 2 seconds, it wants to know what the total area is underneath the velocity graph. Because underneath the velocity graph represents every distance that you traveled, right? If I add up that area, then I have what they want, and that's total distance. So what I'm going to do, right? Basically, I need to integrate from 0 to 2, understanding that there's a negative graph here of the velocity graph. Now, so what I'm trying to get to is the second method to finding total distance, right? Total distance, yeah, equals to area under velocity graph, right? That's important. So sometimes you see questions that have solutions that use integration and the velocity graph, and you're like, why? It's because if I integrate velocity, I get displacement. But if I sum up the area under the velocity, I get total distance traveled. That's why, guys. So this isn't well understood at all. I see that when my students ask me this, right? Sometimes I see something like this at school, don't understand it, but this is the reason, right? So let's try, right? Let's actually do it for this question. Now, the integration piece here feels a bit longer, but let's, for purposes of our demonstration, let's do it, right? So total distance. Yeah, let's actually use the integration method where I go, it's the integral. Now, I know between 0 and 1, see this area down here? It's negative, right? So I'm going to be smart. I'm going to go from 0 to 1, and I'm just going to put a negative in front. Yeah, or an absolute value, same thing, right? Anything that makes that negative area positive. So 0 to 1. Now, of velocity dx, I'll plug in velocity in a sec, plus from 1 to 2 of the velocity dx, right? And I will plug this velocity equation, right, into here and into here when I integrate, right? Into these two parts. All right, let's do it. So you know what? I'm going to plug it in and integrate at the same time. So integrate, yeah, integrate 12. What do I get? 3, so it becomes 4t. Actually, I already have it, right? I have it in the 4t, yeah, in the displacement, plus 3x squared minus 18x, right? There's a negative in front because I know it's a negative area, right? And then plus the same integral. You know what? There's PowerPoint, so I'm going to cheat. Yeah, I do miss doing this in my live lessons, right? But since I'm online, let's just cheat. Right. There you go. Get rid of the limits. Yeah. 0, 2. Guys, I'm sure you guys can all integrate, right? What you get is basically 30, right? Meters. You get the same answer as above. But I just wanted to highlight to you, right? There are 2 ways to do this. Method 1, just by observing where it sort of comes to rest, and the other way, and the other second here. While the other way, method 2 is to use the area under the velocity graph. Both methods are cool. Sometimes I prefer the integration method because think less, right? You just know the graph, and then you basically just integrate between the areas, especially when it sort of has a few sort of positives and negatives where it basically implies it comes to rest more often. All right, that was fun. Let's now explore what I call a special case for simple harmonic, right? In simple harmonic, the most common questions or easy questions that you see have a function that has trig, a trig function of sine, cos, or sine squared, right? They're quite common. Sometimes you might see this case, right, where velocity squared is given as a function of x. In particular, it's a parabola, right? And that's important where normally, and I'll just put it to you now, that the function normally is v squared equals to, right, some sort of quadratic where it's actually not just any quadratic, it's always a negative, right, because it's simple harmonic, right? And in front of the x squared actually has, right, the parameter of n, which relates to the period of motion, right, 2 pi on n, and then plus bx plus c, right? That is usually the structure. You will usually see this guy, right, when you see v squared. Now, what is also linked to this, why can we prove, or how do we demonstrate that this is simple harmonic? We know that it is ultimately linked to acceleration being defined as the derivative of half v squared, right? With respect to x, yeah, that is important. So when you get the v squared equals, when you get this special case, the acceleration formula that you need to use is that one there, right? Not the dv dt, right? Because we're not dealing with functions of t, we're dealing with functions of x, right? Just keep that in mind. All right, let's have a look. So part one, now we know this is the formula, right? And we know it's simple harmonic already, right? It's told to us, yeah? So this is HSC 2010. It's already simple harmonic. Later on in the questions, I'll ask you to prove and show simple harmonic. I'll show you there. I'll show you those when we get there. But find x, particles at rest, buzzwords, right? Yeah, the buzzword there, at rest, v equals 0. Finding x, right? Next one, find expression for acceleration. That's easy. Got to differentiate. Oh, I say that's easy. I got to work this pink formula to do this. So yeah, find acceleration and max speed. Oh, the key word down here is speed. Speed in this case, not velocity, right? Speed has no direction. So if I get a plus minus number, don't care about plus minus, just the magnitude, right? So the max speed occurs when acceleration is 0. Yeah. So let's do this. Part one, find all x values when, okay, sub in v equals 0, right? So v squared is 0, 24 minus 8x minus 2x squared. Hope that can be factorized. Divide everything by, let's divide everything by -2, right? So I get a positive x squared. That's nicely factorizable, yes. Can x be negative? Absolutely, right? You can have negative displacement, right? So that's my answer. Let me just check that. I think that's right. Yep, perfect, done. Yep, nothing too wow about that. That's the x values, that's the displacement where it comes to rest. Now, what that means, right, diagrammatically, before we do anything else, just to illustrate point, if I have right now, right, something that if the origin is there and it's telling me that it comes to rest at 2 and -6, I sort of know that the particle sort of oscillates, right, within this boundary here, right? It sort of moves. So they're my endpoints. I can sort of then gauge, if I take the average of that, the midpoint, right? The middle from all this, right? Because it's simple harmonic. Now, part two, find expression for A. Guys, they want me to basically find acceleration. Now, how do I do that? This using the second pink box, right? I know that A is the derivative of a half v squared, right? I know that, right? That's fact. So what I'm going to do, I know v squared is this. So first thing I'm going to do, I'm going to half everything here. So if I said half v squared, divide all these numbers here, 24, 8, and 2 by 2, I get 12 minus 4x minus x squared. And then I'm going to differentiate. So let me just move this over slightly so I can fit the derivative in so you can see what I'm trying to do. So I'm going to differentiate this guy with respect to x. differentiate this guy with respect to x. Yeah, and then the moment I differentiate this guy with respect to x, this becomes acceleration. And this is just a derivative of this, so -4 minus 2x, right? And just to make this in the form, if I factorize -2 out, I get -2 outside of x plus 2, right? Which is in the simple harmonic form, right? Where n is √2 and the center of motion is -2, which makes sense, right? Because you look over this diagram, -2 is the average, right? Yeah, perfect. Everything makes sense. That's my answer for acceleration. Last one in the HSC, max speed. Guys, I told you before, max speed occurs when acceleration is 0. So right, bang smack in the middle, actually, because basically the particle attains speed maximally in the middle, and then it starts slowing down again. So acceleration is 0, which also means x equals 0. If you were smart about it, x equals 0 is when it occurs. So sub in 0 into the original question there. Let me make sure that's right. Also, when I say x equals 0, x equals the center. Oh, sorry. Silly thing I did there. Yeah, it only attains max speed at the center of motion, yeah? So once you sub in -2 into the original, I got v squared equals 24 minus 8 times -2 minus 2 times -2 squared. What's that, guys? 24, 16, that's 40. 40 minus 8, 32, is it? Now, normally I'll go plus minus √32, but because it says speed, I don't care about the direction, just √32, which is, what's that, 4√2 meters per second. That's all they want in the HSC. Yeah, is that all right? That's the answer, guys. Still another one. Now, I've got 2 more questions prepared just to show you, run through some of these v squared questions. The next one is a classic, right? It's basically from St. George Girls, the classic question that they always ask you, right? They basically give you something that, once again, is simple harmonic, right, in nature. And they were asking you to show this guy, right? And then period and amplitude is the classic question that they ask 4 marks in a 3 paper. Now, before I do that though, let's go through this and make sure we've captured everything. So simple harmonic, time, boom, 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 boom. What now? Guys, when the particle is at the center of motion, the speed is 6. That's important, right? So when it's at the center of motion, right? So if you look at this simple harmonic equation here, right? Center of motion is 1, right? X minus 1, and n, the parameter, is square root of 4, which is 2. Now, n gives you period of motion. Center, right, gives you information here. So when x equals to 1, the speed is 6, right? Now, why did I give you that point? It's because if we're starting, right, let me copy the pink formulas back in, right? This one here. Now, if they start with v squared and they want you to get here, we differentiate. But because in this question they start here and they're going back upwards, we need to integrate. They've given us a point to find the constant, right? That's the point. So part 1, let's do it. Let's do it. Part 1, instead of starting at the v squared and differentiating, we're starting at the acceleration equals to -4x minus 1, right? We're starting with this guy, yeah, which I know, right? Acceleration here, actually I use a pink because it's pink in the formula over here. I know that acceleration is going to be the derivative of a half v squared, and that equals to -4x minus 1, yep. Which means to get rid of the dx, I'm going to integrate both sides, right? Differential equation this, where I move this guy over here, right? So d half v squared equals to -4. Can I expand that, right? It just makes it easier for me to integrate dx, and then I just integrate both sides, right? Yeah, so on this side, I get half v squared. On this side, was that minus 2x squared plus 4x plus c. Right, and then I use my information here when x equals to 1, v equals to 6. Right, so that's a half. 6 squared equals to minus 2 times 1 squared plus 4 times 1 plus c. Guys, if you did this, what's a half of it? That's 18 minus 2, that's 20, is it? Minus 2 plus 2, positive 2, no, 18, 16, is it? 16, yeah, beautiful. So therefore, once you get the constant, plug that back into here and you get half v squared equals to minus 2x squared plus 4x plus 16. Wicked, because then I times everything by 2 and I get the thing I need to prove, right? Therefore, v squared equals to minus 4x squared plus 8x plus 32. Guys, nothing too hard about that. Okay? So in this case, if you start with acceleration, we have to integrate, but I'm using this formula for acceleration in the pink, which means when I integrate, I'm integrating with respect to x. Now, it's very important for you to note there is nothing here in terms of t. There is no t, right? Not integrating with respect to t. T's not here. In this special case, v squared is defined as a function of x, right? Okay. Let's do period of motion and amplitude. Now, period of motion, really easy, just 2 pi on the parameter n, and the parameter n in this case is 2, right? That's 2 pi on 2 n, pi seconds, right? Done. Job done. Yeah, for period of motion. Now, how do I do amplitude again? Now, remember, right, for amplitude, if I was to plot out the motion, right, the center is at, so this is the origin, the center's at 1, that's the center. And I know, right, that to find the amplitude, all I really need to do, right, because if this is a center of motion, I know that it's going to oscillate between one endpoint and one endpoint where the amplitude is between the center and the endpoint. So I need to find an endpoint. How do you find endpoints? Sub in v equals 0, right? Because at both endpoints, the velocity is 0 because it's come to a rest, right? So I'm going to sub in 0 into the velocity formula, right? So when v equals 0, I got this quadratic downstairs here, 0 minus 4x squared. I'm hoping that it can be easily factorized. Let's see. Divide by -4, maybe. Yeah, that's easy. Minus 4, 2, is it? Because of 4 minus 2. Guys, 4 minus 2, great. So therefore, on my diagram here, this endpoint here would be positive 4. This one here would be minus 2. So it doesn't matter which amplitude you take, the -1 or +1, basically between 1 and 4, the amplitude, right? You can see here between 1 and 4, the amplitude is 3, right? So therefore, amplitude is 3 meters, right? So period is really easy because it comes from the formula. Amplitude, just need to find an endpoint. Guys, how's that for this special case where simple harmonic has v squared as a function equals to a function of x? Let's do one more. All right, let's do one more from Gosford, right? Where slightly different, probably easier. It basically says here's a trig function, show that it's simple harmonic. That's like last week. Period, center, and then show that it is similar to that v squared function, right? So nothing too fancy about this. Same deal here. So let's do it. So let me highlight that. So once again, that's my equation. Show that it's simple harmonic, right? Period, center, and then show that this, right? Piece of cake. All right, let's do this. So let's see. I got part 1. I got x equals to 4 minus 2 sine squared, right? Guys, this is just like last week. What I'm going to do is I'm going to differentiate and then to get velocity. Yeah, and then differentiate to get acceleration, right? That is really the key, right? Yeah, so differentiate twice now. So the question is, do I want to differentiate with this squared? If you're amazing with your trig identities, you basically can identify, that looks, whenever you say minus 2t squared, doesn't that look like an identity, right? And that identity, right? Hopefully you guys are pros at this, where you go cos double angle equals to 1 minus 2 sine squares, right? So I just need a 1 there. So I'm going to split this 4 into 3 plus 1 minus 2 sine squares, because then I know this guy here is equal to double angle of cos, right? This makes life easier when I differentiate when it's not a square, because then I don't have to use a chain rule, right? So then displacement is 3 plus cos 2t. All right, sweet. Let's do this, right? So differentiate with respect to time. 3 goes, I differentiate cos, I get negative 2 sine 2t. Differentiate again, becomes negative 4 cos 2t. Great. Now, how do you show it's simple harmonic? Remember, simple harmonic, let me go back to the very start. I need this guy, right? So if I can prove it looks like this guy in this form, acceleration is equal to that form, then I'm done. Now, I can see I'm almost there, because see this, I'll use a different color. See this guy here, right? That's this from the displacement. So I just got to say this guy here, right? X minus 3 is equal to cos 2t. And that is the thing that I'm going to sub into here, right? So therefore, acceleration equals to minus 4 times x minus 3, which is simple harmonic, right? Because you can see it in the form. So therefore, simple harmonic motion, because A, because the reason is because A is equal to minus n squared x minus c, right? 2 marks. Piece of cake. Yeah. Center, so period is easy. Center is easy as well. So for part 2, it's literally just reading off the formula, right? You can see it from here, right? That n is 2 and center of motion is 3, right? So therefore, the period of motion is 2 pi on 2, which is just pi seconds. And the center, not even the amplitude. So amplitude, if you had to find it, then you got to find endpoints and stuff, but this one's easier. That's just 3 meters, right? Nothing too hard about that. Last one, guys. I need to find v squared. So I'm just going to show it like this, right? Where you go, part 3. If now coming back upstairs here, right? If that's v, in this case, right? I'm just going to copy that and go, well, v squared will be the square of this guy, right? Minus 2 sine 2t all squared. Yeah. And what do I get there? I get 4 sine squared 2t. Yeah, and I need to somehow express it in this form, sine squared 2t. Guys, let's see what I get, right? Now, sine squared 2t, I'm going to go, and I know that now. Do I go sine squared equals 1 minus cos squared? 1 minus cos 2, yeah, let's do that, right? Because I got cos 2t upstairs. There's so many ways I could do it, guys. Maybe I'll do it like this, doesn't matter which way. I'll go 4. Let me see, what's a smart way of doing it? Yeah, let's just do it like this, right? So let's go, this is like 1 minus cos squared 2t, yeah? And I know that cos 2t squared, right? Up here, I got cos 2t to be x minus 3, so I'm just gonna plug all this guy into here squared, right? Pretty easy. I don't have enough vertical space, so I'm gonna, let's be heroic. Let's just do it. So equals to 4, 1 minus. Now I know that's x minus 3, so x minus 3 squared. Guys, I'm gonna have to go up here. Equals to 4, So this is still v squared right now, right? 1, if I expand that, was that x squared minus 6x minus 9. Is that what I want? Yes, minus 8. So therefore, v squared equals 4 minus 8 plus 6x minus x squared. Done. 2 marks. Nothing too hard about that, right? Just a different way, but just wanted to show you that the sine squared version is similar to the v squared formula for simple harmonic. So there are some of the different types of questions you see in simple harmonic. Guys, hopefully that was useful. Next lesson, I'm going to do simple harmonic with tides, which can be quite intense. Yeah, hope you tune in for that. Like the video, subscribe to the channel. I'll see you guys later. Thank you.